Hey guys, it's Miss Burns. Today we're going to be learning the basics on how to draw three-dimensional shapes. I think this lesson is engaging and important for students to learn and to analyze three-dimensional shapes because they will have to learn volumes of 3D shapes and many other things, but we're talking elementary, so this goes for a second grade lesson. So we're just going to do the basic shapes today, and my next lesson will be furthering it on more difficult shapes, I guess you can say. I do want to say I'm sorry, I'm not the best drawer, but I'm going to try my best. So first, I want to start out with a rectangular prism. So here we are. This just a basic rectangle. I like to offset my two-dimensional shapes so the vertices are easier to connect. I'm just going to draw the same exact rectangle right here. So here I am. I have two rectangles. Now here we are creating one line, one edge. You just diagonally connect all of the edges. So here is a rectangular prism. The formula for this prism is length times width times height. That equals volume. Teaching this lesson, I want my students to be able to be tested on knowing how many vertices and knowing how many edges. So I'm just going to show an example. So here we are. We have 1, 2, 3, 4. 1, 2, 3, 4. So there's 8, 9, 10, 11, 12. So a rectangular prism has 12 edges. Now here's one vertice, 2, 3, 4, 5, 6, 7, 8. And 8 vertices. Sorry, totally scribbling. These are important to know, especially when knowing how to draw a 3D shape, just to make sure that you're on track on knowing how to draw one. Next, I just want to do a basic triangular prism. This one's pretty basic too, just connecting your vertices. So the volume of this one is 1/2 times base times height times length. So here's your height. I'm not going to add it in until we're done counting the edges and vertices, just so I don't confuse. So here we are. 1, 2, 3. 1, 2, 3. 1, 2, 3. So 3 triangles, 3 sides. So we have 9 edges, and 1, 2, 3, 1, 2, 3, 6 vertices. And then in this formula, it's asking, sometimes it can get confusing on height because we have to know what this is right here. That is your height. Here's your base, and here's your length. Just vice versa. Here is your your length, width, and height. And then I also want to do a cylinder. You're just going to draw your top circle, because if you look at the top of a cylinder, it is circular. And the bottom. So a cylinder, since this is a circle, you always draw your radius line, so you can recognize that. A cylinder's volume is pi. I like to write that just so we know what pi is. R squared height. This is your height. If you notice, this one does not have any vertices. and because it is a circle. So instead of going off vertices, we go off by circles. Next, I want to do a cube. I'm not the best at drawing a cube, but I'm gonna try. You have to kind of keep them close together because it can get to look like a cuboid. It still kind of does. But let's take this as a cube. A cube's volume is length tripled. Since this is an equilateral shape, this is the same, this is the same, and this is the same. So L times L times L, length, length, length. We're gonna go ahead and count the edges so we can just recognize how to make sure we know how to draw. So I'm just gonna draw a star on each edge since I did lines already. So 1, 2, 3, 4, 5, 6, 7, 8, and then we have 4, 1, 2, 3, 4. So we have 12 edges and 4, 4, 8 vertices. When being tested it asks a question like draw a three-dimensional shape with 12 edges, 8 vertices. It gets confusing or complicated because your brain may get these two confused, a rectangular prism and a cube, because they do both have 12 edges and 8 vertices, but it would have to be modified saying with a formula of length times length, or length times width times height. Next, I want to do a right triangle because we are learning about degrees in class. This is a right triangle. I like to put that there so we recognize that. Just super simple, connecting the vertices. Do you guys see that line? Sorry, that one's a little messy. But the formula volume of a right triangle is 1/2 length times height times width. Kind of similar to this one, but instead of base, we are using length. So let's go ahead and count the edges. 1, 2, 3, 1, 2, 3, 1, 2, 3. So 9 edges, and 1, 2, 3, 1, 2, 3, 6 vertices. So like I said, these two can get confused when asking to draw that shape, and these two as well. I am going to attempt to draw a trapezoid. I was working on it and I was struggling, but let's see. So here's my trapezoid. It's gonna be off, pardon me. This one's more complicated. Gotta go, because you have to go out and up. So there is my trapezoid. The volume of a trapezoid is 1/2 times A plus B times height times width. I want to go over these A and B because this is a more difficult shape, so I feel like it needs to be reviewed. So your longer edge is going to be your A length, and your shorter edge is going to be your B length. And then, of course, this right here is your height. Like that right triangle. In triangle, you have to have a straight, your height, and then, of course, your width. Height, width. So let's go ahead and count these edges. This could be complicated because we are missing a few. 1, 2, 3, 4. Okay, there's 4. There's 4. So that's 8. So same as this side. 8 times 2, 16. And then we're going to have this side, 17, 18, 19, 20, 21, 22, 23, 24. 24 edges for a trapezoid. And 1, 2, 3, 4, 5, 6, 7, 8. And 8 vertices. So here is my short lesson on learning reviewing formulas for volumes and learning how to draw 3D shapes and recognizing the edges and the vertices and the lengths, heights, and widths of 3D shapes. Thank you and have a nice night.